Today we're learning about two-column proofs, and we are specifically going to focus on proofs that include triangle congruence and the triangle congruence theorems. So, a proof is kind of like an essay almost in mathematics, where you can prove that something is true by giving statements and the reason for why those statements are true. So typically, this is what a two-column proof will look like. You have your list of statements, you have your list of reasons why you know those things. We're going to start off with like a more broken down wordy version of that, and then we're going to go into the actual tables. Before we get started though, there are two vocabulary terms that I want to give you. So the first one is bisect. Bisect means cut into two equal parts. So if it tells you that one side of a triangle bisects another, it means that the thing that it's cutting is in two equal parts. The other thing is just a quick recap of the reflexive property. The reflexive property states that AB is equal to AB. So something is equal to itself. In this case, a side in this triangle, MK, is equal to MK, right? Because that side is equal to itself. You can also say that side AB is equal to side BA. In this case, A times B equals B times A, because multiplication can be written either way. Okay, so we're going to get started with this. In our first diagram, we have in the figure angle J is congruent to angle L, and you can see that that's marked here, angle J and angle L. It says if side MK, this guy right here, is the perpendicular bisector. So we know bisect means cut into two equal parts, so bisector. MK bisects JL, which means here that these two parts are equal, because that's the definition of bisect. Okay. Perpendicular means that these two lines meet at a right angle. So that means that this is a right angle and that this is a right angle. Now, because they're both listed here at K, we can't just say angle K. We have to list it with all three letters. So the first one is going to be angle MKJ. So the angle that's made here, which we know is a right angle, so angle MKJ is congruent to angle MKL, because both of these angles are right angles. And we know that because this word perpendicular. So then we have, since MK bisects JL, the two segments, first one is JK and LK, or KL, are congruent. Because we have angle J congruent to angle L, we have side JK congruent to side LK, and we have angle MKJ congruent to angle MKL. We have an angle aside and an angle. We know that triangle MKJ is congruent to triangle MKL by angle side angle. Okay, let's look at the next one. So we want to complete the proof about this figure, okay? You can see our first reason says given. So you have been given the information that angle 1 is congruent to angle 2. So these are congruent to each other. And then side AB is congruent to side BC. So these little marks here. We have been given that. Now, we have to fill in our second statement, but we know that it's using the reflexive property. If we remember from above, the reflexive property is when you have something equal to itself. And that happens in figures when you have two triangles touching on one of their sides. So here we know that side DB is congruent to itself. So DB is congruent to DB by the reflexive property. And so we can say that triangle ABD is congruent to triangle, and now we have to match them up. So A to B to D means that we're matching C to B to D. So triangle CBD. And we know that by side, angle, side. Okay, I want you to take a moment to try this last one on the front of this page. So I want you to go through, mark the given statements on your diagram. Notice that the second reason is bisect, so you know what that should be, and then the reflexive property, and then we're going to fill in our triangles and our congruence theorem. Pause the video so that you can go try this out and then come back and check and see how you did. Okay, I'm going to start marking things. So we have side RU is congruent to side TU, so we have those two. And then we have the US bisects RT. So US bisects this to this. So by the definition of bisect, side RS is congruent to side TS. And it's okay if you write these in the other order. I could say that TS is congruent to RS. That order doesn't matter, so long as your letters match up. Okay, by the reflexive property, that's where we have this guy in the middle. So I know that side US is congruent to side US. And so then I can say that triangle RSU is congruent to triangle TSU. Again, if you write these in a different order, that's completely okay, so long as R is matching with T, S is matching with S, and U is matching with U. You could have written this as triangle URS and then UTS. It doesn't matter so long as they match. And that is by side, side, side. Beautiful. Go work on your independent practice, and then you can click the link to check to make sure that you have gotten the two on back.